Good afternoon, friends. So today we will see the operation of functional operation of CRO and function generator. Okay. So these are the proofs which we require for this operation, right? So this is crocodile proof. This one
BNC.
BNC is there, and this is your crocodile proofs are there, right? Other option is there. We can use directly BNC to BNC. This is BNC to BNC. This we can directly use. We can use this or we can use this also. Okay. Now this is your Syntec make, that is model number is 4061, and it is having 3 megahertz function pulse generator and with the 400 megahertz frequency counter inbuilt is there, right? So if you see the screen here, you can see here the model name Syntec 401 function generator, and these are the frequency which we are going to display. And here we are using a TTL analogy. So we have got HTL DTL right now, but we are using a here TTL analogy, transistor logic. Okay, so this is your frequency knob, this is your function generator, and this is modulation, this is attenuation, and this is a menu. From this we can select what we want menu. Okay, now this frequency, so here we can vary the frequency. Here you can see here, now it is in megahertz, now it is in kilohertz. We can set the frequency of our interest. Fine. Now this is your function generator, right? So now the frequency is there, now it is in this one. So here sine wave is there, here triangular waveform, here ramp waveform, pulse generator. Like this we can have different types of waveform we can generate here, right? And we are making attenuation detection 0 volt, right? Now this is the knob, external knob is there, and this is the output port is there. So if you want to measure the waveform, so this is the output to which we have to connect the BNC probe. From this BNC probe we are giving input to the CRO. This is your analog CRO. This is CRT, cathode ray oscilloscope tube is there inside this. So if you see, so there vertical scale is there and here horizontal scale is there. Sorry, this is horizontal scale is there and this is vertical scale. Okay, so vertical scale there are divisions. So in 1 unit 5 divisions are there. Likewise for horizontal as well as for vertical also. Fine. Now these are the knobs. So if you see here, this is volts per division knob and this is times per division knob. By varying this knob we can vary the voltage, and by varying this knob we can vary the time division plus knob, right? So this is your x10, means your multiplying factor by which we can multiply by 10 times of the particular waveform. And this is xy mode, means what? Two modes are there, two channels are there. Two modes means what? Two channels. So this is one channel and this is another channel. Two channels are there, X channel and Y channel. Both channels are there. So we can feed signal to one of the channel, or if I want to see the waveform of through both the channels, so I can use these two channels and I can put it in XY mode. Okay. So now we will see. Now I have put it in a sine wave mode with a frequency 1.04 kilohertz. So in CRO you can view clearly that it is a sine waveform, right? Now if I change the function, means instead of sine waveform, if I make it square waveform, triangular waveform. For example, if I make it a square waveform, so we can view here that we are observing a sine waveform, square waveform on a CRO. Likewise, if I change the function to a triangular waveform, so here in CRO panel we can view a triangular waveform respectively. And likewise, if you change my function into ramp, so ramp waveform can be observed. So this is what the basic you can say advantage of our function is that ready-made function generator has been available here. So depends upon our requirement, we can choose the particular waveform with the help of this function button. Right, now we are making sine. Okay, now we will measure the waveform, right? So there are two parameters that need to be measured from a waveform. One is your frequency, other one is your voltage. So the frequency is lying on your x-axis here and voltage is lying on a y-axis, right? So how to measure the frequency from here? So we don't know what is the frequency which is given. So from this, if I want to measure the frequency, so how we will measure? So first you adjust the sine wave in 1 cycle, right? We are interested in 1 cycle. So my 1 cycle starts from here. Okay, you see here, from here, and it ends to here. Okay, so in all there are 10 divisions, right? Now here see what is my times per knob division. that is 0.5 millisecond. Okay, so what is the formula? What I said, that is time period measurement is equal to number of horizontal division multiplied by times per knob. Okay, now my times per knob is 0.5 millisecond, right? So there are different ways. So simple way is that for 1 unit you have to calculate what is the time duration carried by my one division, right? So for that, how you can do is that 0.5 millisecond divided by, in 1 unit you have 5 divisions are there, right? So 0.5 millisecond divided by 5, that will be equal to 0.1 millisecond. So now this is the unit of 1, this is the value carried by 1 division, that is 0.1 millisecond. Now you see here the sine wave extended here from here to here, in that we have got 10 divisions, right? So 10 division multiplied by, what is the unit of 1? 0.1. So 10 divided by 0.1 will be 1 millisecond. So your time period will be 1 millisecond. If you make the inverse of this frequency, that is 1 upon f, that is equal to time period. Time period is equal to 1 upon f. So t is equal to 1 upon f. So t will be 1 upon f is what? 1 millisecond. That comes out to be 1 kilohertz. So here you can view here. So my frequency is 1 kilohertz. So this is how we can calculate a frequency from this CRO. Same way you can calculate the voltage on a CRO, that is y-axis. So in that same division we have to take how much divisions which carries my waveform, right? So if you see here, my waveform is been covered within 2 units, right? That means what? 2 blocks or 2 units, or you can say 10 divisions, right? So same 10 division, and what is the voltage is there? 5. Likewise you can multiply number of divisions multiply by volts per division. Now that comes out to nearly 5 unit. Okay, so this is how we can measure the voltage or frequency in a CRO, right? So one more thing I would like to tell you, that the ground button is given here. So when you push this ground button, you will get a straight line, so which will help you to align my this waveform. And if you release it, so you will get exactly waveform. Then this is XY mode. So why this XY mode is there? Because if you want to measure the unknown frequency, right? Means what? One frequency is known to us, and if you want to measure the unknown frequency, so with the help of this least charges pattern we can measure. So by pressing this button XY, we can have both frequency and since I am using only one channel here, right? If you see here, only one channel is engaged, so only I am getting. If 2 channels are engaged and if I am pressing the XY mode, so you will get some pattern, and depending on the pattern we can measure the unknown voltage. Now here I release here. Now here mono button means what? I am using a single one, and dual means what? I am using both channel. So hope so you might have understood what is the function buttons which is been mounted on a analog CRO along with the function generator. So hope so you will find this video more useful. So do like, share and subscribe my channel. Thank you.